Hey guys, we're back with the notes for 6.0. This is what you should be working on after the test. Reminder that this is a review. Everything that you're doing in 6.1 is not any new information. This is all about graphing lines and writing equations of lines coming straight out of Algebra 1. Okay? All right, so I'm going to have you pause the screen for just a second, copy everything that you see on this top part, and then we'll briefly talk through it before we start some problems. Perfect. All right, so once you have all of that written down, this is just supposed to be some quick reference notes. Rise over run is what you guys frequently call slope. I want you to understand that that is the average rate of change. Now, for a line, we have constant rate of change because it is constantly rising and running the same value. Now, when we talk about something in a parabola, obviously the rate of change is changing. If I look at the bottom of a parabola, it's only increasing a little bit each point. But as we move up farther out, that average rate of change is increasing, okay? So as you move through Algebra 2 and Pre-Cal and Calculus, average rate of change is no longer just rise over run, okay? We start talking about it more numerically. I wrote out kind of the formula from Algebra 1, and I wrote where it is normally in an equation for our like mx plus b guys, okay? All right, next thing we want to talk about is our parallel lines have the same slope. Perpendicular lines have opposite reciprocal. Remember, opposite reciprocal means that they are flipped and they are also different signs. So a -2 is like saying a -2 over 1 and a positive 1/2. Those are flipped and they're also different signs. 5 over 2 and -2 over 5. They are flipped fractions. That's the reciprocal. And opposite means different signs. Horizontal and vertical lines are dictated between a y equals or an x equals equation. Horizontal is a zero slope. The way I like to teach that is that you could draw a z with it to make a zero. A vertical line has an undefined slope. I like to remind my freshmen that you can use u and d out of that line and make it an undefined. Okay, that's just a quick reminder in case you ever get stuck. All right, so let's actually start working through some of these problems. First question says, determine the average rate of change, so it's asking you to find the slope, between these two linear points. Okay, I'm going to zoom in real quick. We are going to subtract the y's. It does not matter if you do 7 minus 6 or 6 minus 7. It's going to give you the exact same thing, as long as whichever order you start in, you do the same on the bottom. So if I start with the 7, I have to make sure the -4 is underneath him. So -4 minus a -1. If I start with the 6, I have to make sure his partner's underneath. So -1 minus a -4. Quick reminder that minus a negative is really adding. So on this problem, I would get 1 over a -3. If I do this problem, I would get -1 over a +3. Both of those come out to be the exact same number, -1/3. Okay. We're going to do the same thing for the second point. It says determine the average rate of change for f of 3 equals 7 and f of 5 equals 11. I'm only going to do this one way. Reminder that the y's are what it equals. The f of x is what's in the inside. So if I rewrite it kind of like this to show you. Okay. So in this problem, I would do 11 minus 7 on top. And if I start with 11, I have to start with his x. So 5 minus 3. 11 minus 7 is a 4. 5 over 3 is a 2, and we always simplify. My slope between those, my average rate of change, is a 2. Last one at the bottom, determine the average rate of change from this equation. We are going to need to put it in y equals mx plus b form in order to get our m. You can't, I mean, there are ways you can just look at it and find that, but the expectation is that you're rewriting, okay? All right, so in order to do that, we're trying to get y by itself. First thing I want to do is move everybody who's not the term of y to the other side. So I'm going to move 2x to the other side and 17 to the other side. And when I do that, I have to remember that I changed the sign. So -3y equals a -2x and a -17. Notice I'm putting them kind of in order with the mx first and the constant at the end. That -2 is not my m yet. Next thing I'm going to do is divide out that -3 from everybody so I can get the y by itself. 2/3 doesn't simplify, but negative divided by a negative makes a positive, so 2/3 x. 17 does not divide by 3, but again, negative divided by negative makes a positive. It's okay that that equation's ugly because the only thing we want is my slope or my average rate of change. So this right here is my answer, 2/3. Okay. If you missed anything on this screen, go ahead and pause it. Otherwise, I'll meet you on the next page. All right, so I'm going to ask you to pause the screen for just a second. If you want to use colors, that's great. If you want to highlight, that's great. If not, I'm going to give you just a moment to copy down everything that you see on this screen, and then we'll move on. Perfect. All right, so there's a lot of information here. One thing is just M and B coming out of your equation. Remember, M is your slope. It's your rise over run. B is your y-intercept. That means it's the point where you begin. When you graph, it's on the y-axis. It is the point. If I could write that out for you, it is the point 0, B. Okay. All right, second thing we want to talk about is standard form. Standard form has two specific rules. Number one, A is not allowed to be a negative, and B is not allowed to be a fraction. So if I had an equation like this top one, and I see that my A is negative, what I would do is I would change all of the signs to make that 2 a positive, 4 a negative, 6 a negative. That's how we would fix it. Okay, so if you ever rewrite something and you get a negative A, just sort it out, change all the signs. Next thing is your B is not allowed to be a fraction. That's like this guy. If that ever happens, you are going to multiply the whole line by whatever the denominator is so that you can cancel it. So 4 times 2 give us 8x. The 4's cancel, giving us a negative 3y. And then 4 times 5 is 20. That's how we would change it. Okay. All right, the last way to graph in standard form is to get your x-intercept and y-intercept. To get your x-intercept, basically you're making the y portion a 0 and just dividing by a to get your x alone. If you were trying to get a y-intercept, that means you are completely getting rid of the x component, dividing by the value b to get your y alone. And I'll show you a couple of those. All right, let's talk about this first one. So we're graphing with y equals mx plus b on the top equation. So if I look at this, I've already written out for you my slope is a negative 2/3, my b is a negative 1, so I'm going to put my b on my graph. My first point is going to be at negative 1 on the y-axis, and then I am going to repeat the slope over and over. Since it's negative, that means my line needs to be going downhill, okay? So we're going to be moving down 2 and over 3 before we get to our next point. And I just repeat that over and over. The expectation is that you are graphing as many points that fit on the graph. You are not just doing 2 and then kind of winging it, okay? All right. Second equation, you are trying to do this graph from standard form, which means you have two options. You can either do x-intercepts, which I did to one side, or you can rewrite it to y equals mx plus b. Intercepts are way faster, way easier if they work. So let me show you what that looks like. All right, so if I come back up here and I say I'm trying to find my x-intercept, I'm going to do this in purple. Don't write this down, just watch. If I want the x-intercept, I completely get rid of the y term. Get rid of his y, get rid of his coefficient. This literally says 5x is 10, divide by 5 gives me 2. In other words, I took my c part, divided it by my a part, and that gave me my term. Okay? I'll show you what that means in just a second. If I was solving for my y component, my y-intercept, I would get rid of all of the x part. Make sure you keep the sign right here. 2y equals 10 makes my y a 5. All I did was divide my c by my b component, and that gave me my y-intercept. Okay? Most of you guys can probably do that stuff in your head. So when I graph that, I have 2 points. I have a 2 on my x-axis, which is like a 2, 0, and I have a 5 on my y-axis, which again is like 0, 5. I can connect my 2 dots just from those 2 points. I am not expected to repeat that one over and over. I would be done. Okay? I want to show you one more time doing a rewrite in case intercepts doesn't work. Let's say you did intercepts and you got a number like 10 over 4. I don't know where that 0.5 over 2 is on a graph. It's not going to be exact. So we would want to do it a different way. Okay? All right, let's say you needed to make it y equals. You would again move the 5x to the other side. Make sure you change the sign. So 2y equals a negative 5x. The 10 does not move, so he stays positive. We would divide everybody by 2 to get rid of that and get y by itself. -5 over 2 would be my slope. +5 would be my y-intercept. So this is my m and my b again. And if I graph that, it would be the exact same thing. So I begin at 5, I went down 5 over 2. That made my graph. Okay. If you need to pause the screen at all, copy what you see, that's fine. I will meet you on the next page. We have one more. Perfect. All right, on this next page, it tells you to graph on page 8 of your packet. So if you look through your packet, there should be a page with blank graphs on it. I'm going to kind of be jumping back and forth between those on mine so you can follow along with that. Okay. All right, first one, we are graphing -1/3 x minus 3. So that means I need to begin at -3 on my y-axis, rise a -1/3, that means go down 1 and right 3. You are expected to put as many points on the graph that you can fit. Okay, so your graph should look something like that. Why don't you guys try to graph problems 2, 3, and 4? Pause your screen, try those, and then let's check them. No, like really pause it, try them, and then we'll check. Great. Okay, so 4x plus 2 is my next problem. So we are going to graph 4x plus 2. We're starting at +2. If you have a slope of 4, what that really means is 4 over 1. So you are rising up 4 and only over 1 space. Same thing going backwards. I'm going down 4 and left only 1 space. Okay. So graph for the second problem, number 2, should look like this. Problem number 3 tells you it's wanting you to solve it with x-intercepts. Okay, so first thing I would do is make sure that I would rewrite it into a basic standard form. So -6x plus 3y equals 18. And that way I can find my two components. So if I want the x component, I'm going to do 18 divided by a -6 equals -3. That's my x. And if I want to do the y component, I would get rid of the x's. 18 divided by 3 equals 6. So -3 on the x, 6 on the y. Let's look at that. This is my third problem. So -3 on the x, 6 on the y. My graph would look like this. Okay. Again, if you need to pause any of these, I will do that as soon as we are done with number 4. Number 4, I've already laid it out for you. It asks what are the x and y intercepts. So my x-intercept means I do the c divided by the number with x, so that's a -3 again. If I do the y component, I'm doing c divided by the number with y, which would be a +2. So -3 on the x, +2 on the y, last one. So +2 on the y, -3 on the x, and we can connect our 2 points. There we go. All right, if you need any time to pause that, copy down problems 1 through 4, go ahead and do it now. Otherwise, we're going to go back to page 6 and wrap up these notes. All right, so page 6. The next part is all about answering a system, meaning 2 equations or more, using graphing. So I'm going to graph the 2 equations as soon as you write them down, and then we're going to talk about what the answers look like. So if you would, will you go ahead and copy everything you see right now in the pink and the blue and the black, please? Perfect. When you have that all written down, we will go ahead and graph them. So I'm going to graph my first equations in pink. So my first equation, I'm going to graph -1, rise 2, run 3, putting as many points that fit on the graph. Ooh, I did that wrong. Sorry about that. Rise 2, run 3. Okay. And I'm actually going to do all the pink ones right now while I have pink in my hand. Okay, on the second problem, my x would be a 6, my y would be a 4. And on that last problem, my x would be a 6, my y would be a 4 one more time. Those are the same equations. Okay, I will pause it at the end of this so that you can copy any of these that you are missing. Okay, let's graph all our blue ones. On my blue one, I'm going to be starting at 6. Remember, 3 means 3 over 1. So if I follow that all the way down, the goal is that you land on a point in common. Okay. Let's look at the second problem. This one I would begin at 4. And I would be going, actually we're going to change that. Nope, we're good. Begin at 4, going down to right 3. Up to left 3. My graph's a little bit off. Okay, and last one. This one we're going to start at -2, down to right 3. Remember, I'm putting all the points on the graph that I could fit. All right, let's pause the screen for just a second. Make sure you have those graphs written down before we talk about answers. All right, speaking of answers, you will have one solution if the lines cross. That means you would name the point where they cross. In this case, it's -3, -3. It's that point right there. If your two lines are the exact same line, means they start at the same spot, they rise and run the same way, they land on all of the same points, we would say they have infinite solutions, or you could say they have all real numbers in common. Okay, there are infinite possible solutions to that. The last one is no solution. That's what happens when our lines are parallel. Remember, that happens when the lines have the same slope. So same slope, but they started in different places. That means they have no solutions, no points in common. Okay, if you need to pause, write down anything, go ahead and do that. We're going to do 3 examples, and then we are done with these notes. All right, example number 1, we are going to graph using intercepts because they're coming out of standard form, but we are graphing a system. Okay, so for my x-intercept, if I do 8 divided by 4, I get 2. If I do 8 divided by 1, I get 8. So we're going to graph these 2 points, 2 on the x, 8 on the y, and connect my dots. For the blue equation, I'm going to do 9 for the x, that's 18 divided by 2, and then -6 for my y, 18 divided by -3. So 9 on the x, -6 on the y, and we're connecting these 2 dots. Ooh, and that one's a little crooked, my bad. There we go. All right, so my solution again, because they cross, is the point where they cross. So we're going to use this guy, 3, -4. If you need to write down any of that, go ahead and do it now. We're moving to the next one. All right, this problem asks us to solve graphing, but we're going to do this with a rewrite. It's pretty smooth rewrite because both of these have a y by themselves. So all I'm going to do is move the 2x to the other side, -2x plus 4. I'm going to do the same thing for blue. Move the 2x to the other side, so -2x plus 1. What do you notice about both of these guys? They have the same slope. They have the same slope, but look at their y-intercepts. Because their y-intercepts are different, that means that we know they are not going to be crossing. They should end up having no solution. We are going to graph that because the answer is no solution, but the show your work part is the equations on the graph. All right, so we have a -2x plus 4. Again, when you're using slope, you are expected to graph as many points that will fit on the grid. And I think our other equation is a +1. Let's do the blue one. We're starting at 1, down 2 over 1. And we were right. They do not cross, which makes them parallel. That gives them no solution. All right, last problem is going to be a little bit of a throwback. So if you'll flip the page to number 7, the top problem is an example. It is not a assignment problem. So you will be doing this one for homework. And obviously the bottom part too. But the first guy where he just says example, I want to do one with the absolute value because I do expect that you can graph this, but I want to refresh our brain, okay? All right, so let's talk about the first equation in pink, and then we'll do the second one for blue, okay? All right, so in pink, remember absolute value is shaped like this, that down 2, because it has a -2. So instead of starting at 0, 0, I'm going to start at a -2. And I'm going to remember that there is no stretch. So my graph is going up 1 over 1 each time. And if I can graph it, you can graph it. So please connect all the dots that will fit. Okay. If I graph y equals 2, remember that's kind of like saying y equals 0 x's, but I do have a 2. So I want to hit the y-axis on 2 and use a 0 slope. So it's going straight across. Now, if I ask you on this problem, how many solutions do you have? Well, you should have 2 solutions because those graphs cross at 2 different places. So I'm going to have this point, -4, 2, and I'm also going to have this point, +4, 2. Okay, should end up with 2 answers to that graph. You will get the same kind of answer for problem number, whatever this one is on the right-hand side. Okay, all right. You are not expected to start the assignment until we get into class. If you would like to graph it and get it over and done with, that's awesome, but you are not expected to have it done until we start it in class together.